The Rutherford atom clearly defined that the atom cannot exist in a planetary model orbit. Now we start to look at the quantum mechanical model of the atom, and quantum mechanics is the science that successfully describes how an atom can exist. What we're going to find here is that electrons live in energy levels. So in the quantum atom, so once an electron is in an energy level, this electron does not accelerate, and therefore emits no radiation, which implies the atom is stable. Now we want to talk about jumping electrons. What we say here is that when I look at the energy levels, let's say for the sake of argument that there are 3, so that means I have 1, 2, 3 energy levels. Electrons in the lowest energy state versus electrons in the higher energy state and what this energy level is saying here is that as you go upwards in energy level, there's an increase in potential energy. It's electrical potential energy. So a higher energy state implies that this is an excited state. When an electron is in the lowest state, this is not an excited state. When electrons jump, they emit light. So what we find here, if an electron jumps from the 3rd to the 1st energy level, this is a bigger jump, which then implies that it has more energy. If the electron jumps from the 2nd to the 1st energy level, this is a smaller jump, therefore less energy. But the way this relates to light emission is a bigger jump implies more light energy. A smaller jump means less light energy. I now have to talk about the electromagnetic spectrum. An electromagnetic spectrum is just the word we use in everyday language as light. Light comes in classes. And so when I say the word spectrum here, this just means the different kinds of light. And it turns out that there's 6 kinds. One type of light, known as visible light, has a spectrum that starts at violet and then goes to blue, green, yellow, orange, red. And so what we find here is that the violet end of the spectrum is the high energy light. The red here, which is at the opposite end of the spectrum, is the low energy light. So you could see that somewhere in the middle, roughly around green or so, is the mid energy light. So the way people talk about the spectrum is they call it the RGB, so it means here that RGB means red, green, blue. So blue light has high energy. Red light has low energy, and green light has mid-level energies here. If you look at the spectrum, you could see that energy that has more energy than blue is the violet, whereas yellow light has more energy than red but has less energy than green here. So when an electron falls a higher energy level to a lower one, the electrons emit light of a particular color related to the size of the jump. So let's write that out. When an electron jumps from a higher to a lower energy level, the electron emits light according to the size of the jump. Let's draw pictures according to these jumps here. So imagine that I have a 4 energy level atom. So if I go 1, 2, 3, 4, so I got 1, 2, 3, 4. And if I have an electron that's in the 4th shell, and then this electron falls all the way down to the bottom. Because this is a bigger jump, and violet has the highest energy, then this thing is going to emit violet light, because it has the biggest jump here. So if I redraw this atom again, And this time, I have an electron that's on the third shell. What you're going to find here, when the electron jumps, since this is a smaller jump, it emits lower energy light. So in this case, it would emit green light. And the smallest possible jump here would be from the second to the first. It would emit the lower energy light, so therefore it gets red light. So when people observe energy levels in atoms, it's the emission of light that tells you about the structure of the atom. And this is summarized by what's called atomic spectra. So if I had an electron that could jump like this here, this is what you would see here. So since there are, let's say that these are the only 3 possible jumps. It turns out that there's more. But what you would find here is that because of the various ways for the electrons to jump, what you would see here is that with these 4 energy levels, I could do one of 3 things here, right? I could have 1, 2, 3, and if they jump here, and if I have this guy here, it's going to jump all the way down here. If I have this guy here, it's going to jump there. And if I have this one, I get this. So then that means I'm getting these colors of light that are being emitted by the atom. How this is observed is with atomic spectra. And what you would see then is that you would see 3 lines corresponding to each of these colors. So I'd have a violet, I'd have a green, and I'd have a red. So what you see here is that, look at the spacings here. The way I drew them is that they're equal in distance, and therefore, because these energy levels are equal in distance, then what I'm going to see here is I'm going to see these 3 colors. And this atomic spectra is unique to the energy level structure. And because it's unique to the energy level, what we say then is that these lines here are the fingerprints of the atom. So if I was to show you an image here, you could see that you could see right here that we have what? We have beryllium, copper, magnesium, strontium, and titanium, and you could see that the lines that they have are all different here. So this line structure tells us that each atom has a unique atomic spectra. To show you the number of possible spectral lines that an atom can have here, I want to compare a 3 energy level system to a 4 energy level system. So now we want to compare a 3 energy level system to a 4 energy level. So if I draw the 3, there are going to be only 3 ways that an electron can jump from a higher energy state to a lower energy state. So let's count them. So let's say that I have this color blue. The biggest jump is going to have the highest energy light. Now that blue can jump to, let's say, instead to here. And what you're seeing here is that in this case here, you could see that this atom, the blue atom, can jump from the first to the second, the third to the first, and the red can jump from the second to the first, but there's a third possibility. And the third possibility here is that I could have this blue one, instead of jumping to the first, it could first jump also to the second. So therefore, what we say here is that electrons only have 3 possible ways to jump to the lowest energy state, and that implies that there are going to be only 3 spectral lines. Now, if I look at the 4 energy level one, I have 1, 2, 3, 4. Then we can have an atom that does what? I can have an atom that starts here, or an electron that starts here. And how many ways can that guy jump? Well, it could jump to the 3rd level, it could jump to the 2nd, it could jump to the 1st. Now if I pick my 2nd one, how many ways can it jump from the 3rd level? It could jump from here to here, or it could jump from there to there. And if I look at the last case here, the red here, there's only one way that it could jump. So you're seeing here is that this structure says that I can jump 1, 2, 3, 4, 5, 6. So here, there are 6 possible jumps, but there are 6 possible jumps. You will see 6 spectral lines.